Hi, in the last week videos, we talk about how do we find out the Laplace transform of a piecewise function, right? Because we were able to write the piecewise function using the indicator function, u sub 0 something, or u sub 1, u sub 2, like that, right? Lowercase u, or unit function, you say. So we're able to write a piecewise function as the combination of the unit function or the indicator function, okay? And then we were finding some of the Laplace transform of some of the indicator functions. So let me quickly review that before I go to the differential equation with discontinuous forcing function, okay? We know that if f of t equals to 0 if t is less than c, and 1 if t is greater than c. What does the graph look like? Suppose there is a c there, right? So the graph is 0 for less than c, it is 0 for less than c, and then 1 for greater than c, right? This is 1, you know that? So this is a step function, right? This is a piecewise function, right? So you see that this is 0 on the left of c, and then on the right and c, and on the right of c it is 1, okay? So this can be written as u sub ct. This is called indicator function or unit function. This is how you can write. U ct means after c the value of u is 1 everywhere. After c the value of u function u is 1 everywhere. So this is u, right? This is u, this is t. You see that? Now, thus, if you have a function that is 1 between c and d and then 0 elsewhere, what does that mean? That means, suppose you have a function like this and then there is a c and d. Let's say there is c here and there is d here, right? So if it is 1 in the between c and d and then 0 everywhere, there is 0 everywhere, then what can you write? If you write UC means it is 1 after C. If you write UD, it is 1 after D. But if you do UC minus UD, then you will get 1 between C and D and then 0 elsewhere, right? That's what you get. So you can write FT. So here FT can be written as F of T, can be written as UCT. But here F of T can be written as this thing, can be written as UCDT. That means there is 1 between C and D and 0 elsewhere, right? That can be written as UCT minus UDT if you want to write using the indicator function, right? UCT minus UDT. Now, also recall what is the formula to find out the Laplace transform of UCDT? To find out the Laplace transform of UCDT, that will be e to the negative cs minus e to the negative ds over s. Why? Because the Laplace transform of the indicator function is e to the negative cs over s. If there is uct, then the Laplace transform will give you e to the negative cs over s. It is very easy to see that, right? Because you can just apply the formula of the Laplace transform to this 0 and 1. One term will be 0, and then you just find out the integral of the other. So it will be like e to the negative cs and then 1. So you just find out the integral of e to the negative cs, right? That will be e to the negative cs over s for s greater than 0. If you use that formula, then you will get the Laplace transform of this term will be e to the negative cs over s minus e to the negative ds over s. So if you combine that, you will get e to the negative cs minus e to the negative ds over s. So this is the Laplace transform of this indicator function, right? So the Laplace transform of this indicator function is just that. So that's why you use that. Okay, now let us take an example. Suppose f of t is a function which is 1 between 0 and pi half and 0 greater than pi half, t greater than pi half, okay? So find the Laplace transform of f of t, this function. This is same as u0 pi half, right? Because you see that it is 1 between 0 and pi half and 0 elsewhere. So here f of t is equals to u0t minus u pi half t. u0t is everything right of 0 is 1. U pi half t is everything right of pi half is 1, right? So you see that? So if you look at this, how does that graph of ft look like? There is 1 here, right? Between 0 and pi half, the value is 1. the value is 1, and then 0 elsewhere, right? This is the graph of this function ft. So this is t, right? So this is a graph of function ft. Now, how do you write this using the indicator function? If you write u0, u0 is everything right of 0 is 1. Whole thing is 1. Minus u pi, everything right of pi half is 1. So if you subtract u pi half from u0, then that's what you will get. That's what the ft you get, right? Now, if you find out the Laplace transform of this, you take the Laplace transform on both sides. You get Laplace transform of u0t minus Laplace transform of u pi t. Now use this formula to find out the Laplace transform. If you use that, you will get e to the negative 0 times s over s. That will be e to the negative 0 times s will be e to the negative 0. That is 1, right? 1 over s is the Laplace transform of that. Okay. Similarly, Laplace transform of u pi half. Just use that, e to the negative pi half s over pi half times s over s. That's what you get. If you combine that, you get 1 minus e to the negative pi half s over s. Now, if you want to take the inverse Laplace transform, there is the formula to find out the inverse Laplace transform, right? If you want to take the inverse Laplace transform of e to the negative cs times fs, the formula is uct times function of t minus c, where this lowercase f has the Laplace transform uppercase f. Okay, where the lowercase f has the Laplace transform uppercase f. So for initial of that, you write e to the negative cs times the inverse Laplace transform of fs will be, because there is e to the negative cs multiplied, so you will write lowercase ft minus c, where fs is the Laplace transform of lowercase ft. Now, let us take this Laplace transform of this function. What do you get? Inverse Laplace transform. Inverse Laplace transform of 1 minus e to the negative pi over 2s over s is equals to, you can write the inverse Laplace transform of 1 over s minus inverse Laplace transform of e to the negative pi over 2 times s, right, over s. Now, what is the inverse Laplace transform of 1 over s? That is 1, because the Laplace transform of 1 is 1 over s. That's the reason. Okay. And inverse Laplace transform of e to the negative pi half times s times 1 over s. But because I want to write in that form, you see that? E to the negative cs times fs. Okay. I can write that way. Now, it is like c is like negative pi half, right? It is like cs. You see that? So you can write 1 minus the inverse Laplace transform of this whole thing will be u to the ct, that's c, that is u to the pi half t times, this is like uppercase f, right? F of s. What is the inverse Laplace transform of that? Is lowercase f, right? So this is like, what is the inverse Laplace transform of 1 over s? Is 1, right? 1. But you cannot just write ft here. You write ft minus c. You write f of t minus pi half. But what is lowercase f? Lowercase f is 1. Why? Because the inverse Laplace transform of 1 over s is that lowercase f. Okay, that is 1. So f of t is 1. That's why f of t minus pi half is also 1. So you can add 1 minus pi half t times 1, because this is also 1 there. Okay, that is also 1. So which is 1 minus u pi half times t. So you should be able to write the Laplace transform and then inverse Laplace transform of the indicator function as well. Okay. So the next thing I want to do is I want to give, let us see one example where we have the right hand side function is a piecewise function or step function. Okay, so that may not be the continuous function. The right hand side function is not continuous function or step function there, maybe piecewise continuous. So so we want to solve this differential equation. We have y double prime plus y equals to ft, where ft is given like that, and y at 0 is 5 and y double prime at 0 is 3. Okay, so to solve this equation, what we need to do is we need to take the Laplace transform on both sides, right? So take Laplace transform on both sides. So this is the Laplace transform. So what do you get? You get Laplace transform of y double prime plus Laplace transform of y equals to Laplace transform of ft, right? What is ft though? Ft is this, right? So we found out the Laplace transform of this function already, right? So how would that look like? Let us find out that. So y double prime. What is the Laplace transform of y double prime? It is s squared times Laplace transform of y minus y s times y at 0, right? Minus y prime at 0. That's what you get, right? That is the Laplace transform of the first term plus Laplace transform of the y equals to, what was the Laplace transform of f of t? So we got 1 minus, do you remember how we did that? We wrote that inside function as 1 minus u, right? And then pi half, right? Pi half t, and then we found the Laplace transform of this guy, right? So do you remember what we got? We got 1 minus e to the negative pi half times s over s, whole over s. That's what we got, the right hand side, right? Now let us use the initial condition there. We got s squared times, what is ly? It stays L Laplace transform of y minus s times, what is y0? 5, right? So let me write down 5s minus, what is y prime of 0? Is 3, right? And then plus you got Laplace transform of y equals to 1 minus e to the negative pi half s times s over s. That's what you get, right? Now let me move this term without Laplace transform to the right side. You get, and then factor out Laplace transform. You get s squared plus 1 times Laplace transform of y equals to 5s minus 3, right? And then plus 1 minus e to the negative pi over 2s divided by s. Okay, now what I'm going to do next is I am going to divide both sides by s squared plus 1. Well, how do I do that? Is you get Laplace transform of y equals to 5s minus 3 over s squared plus 1 plus, right, 1 minus e to the negative pi half s over s times s squared plus 1. That's what you get. You see that? This is what you get. All right. So how do I find? So our goal here is to solve for y, right? So we'll have to take the inverse Laplace transform. Okay, guys. So to take the inverse Laplace transform, so what I'm going to do is I want to first of all find out the partial fraction. I need to separate this because there is a product in the denominator, right? So I want to separate these first, okay, and by using the partial fraction. So let us find out what is the partial fraction of this guy, one, because you know that, you know what, this can be, let me write on one more term and then it will be clear. 5s minus 3 over s squared plus 1 plus 1 over s times s squared plus 1, right? And then minus e to the negative pi half s over s times s squared plus 1. That's what you write. Okay, now you see that this, the second term and the third term, I mean, you can definitely separate these. How do you separate that? So it will look like, I mean, I can do at the same, you know what, I can basically write this as, this as equals to, you can write 5s over s squared plus 1 minus 3 over s squared plus 1. You can write that way and you can separate that way. You see that the third term and the fourth term have product of the terms in the denominator. So I want to find out the partial fraction for that. Okay, so what I can write is, let us use the partial fraction. 1 over s times s squared plus 1 can be written as, how do you write that? You can write a over s plus bs plus c over s squared plus 1, right? So what you can write? You can write 1 equals to a times s squared plus 1 plus bs plus c times s, right? If you take s equals to 0, what do you get? You get 1 equals to a, and everything will be 0. A is 1, right? If you take s equals to 1, what do you get? You get 1 equals to 2a plus b plus c, right? You see that? So what do you get? A is what? Your a is 1, right? So you get b plus c equals to -1 because a is 1. So b plus c is -1, right? So how about if you take s equals to -1? What do you get here? If you take s equals to -1, you get basically you get 1 equals to 2a plus b times -1 plus c negative b plus c times -1 times -1, right? What do you get? 1 equals to 2, okay, plus, you see how much is that? C minus b, and if you multiply by negative, so it will be b minus c, right? So what do you get? So b minus c equals to -1, that's what you get, okay? So b plus c equals -1 here you get b minus c equals -1. If you add these two, what do you get? You get 2b equals to -2. So b equals to -1 as well. If you put b equals -1, what do you get? C equals to 0, right? If you put b equals -1 here. So what do you get? Finally, you get, let me write down here. You get a is 1 over s, and then minus bs is minus s over s squared plus 1, because c is 0. That's what you get. You see that? So this term can be written like that. How about this term? So similarly, you can write also, let me use different color, also e to the negative, I want to use different color, e to the negative pi over 2s times 1 over s times s squared plus 1 can be written as what? E to the negative pi over 2s, and then it will be 1 over s minus s over s squared plus 1. That's what you write, right? And if you distribute, you will get e to the negative pi over 2s over s minus s times e to the negative pi over 2s over s. That's what you get. Or you can write negative pi over 2s first. Okay, let us do that, because we'll have to take the inverse Laplace transform later. That's why that will be in the standard format. So times s there. Okay, so we can write this as that way, this term as that way. So let us write down very final form of this. Okay, so of that expression. So what you get there is, so therefore you can write Laplace transform of y is equals to 5s over s squared plus 1 minus 3 over s squared plus 1 plus what do you write? 1 over s, because for this one you can write 1 over s minus s over s squared plus 1, right? Similarly, for the last one you write plus minus, there is minus there, right? Because there is minus sign there. So minus, this will minus, the second one will be plus, right? Minus e to the negative pi half s times 1 over s, and then plus e to the negative pi half s times s over, by the way, there is s squared plus 1 here, right? Over s squared plus 1. That's what you get. Now, what we do is we take the inverse Laplace transform, okay? So let me write down that. Take inverse Laplace transform. Inverse Laplace transform. Also, we need to use what is the formula? We know that inverse Laplace transform of e to the negative cs times uppercase fs equals to what? You write the inverse Laplace transform of this is uct times f of t minus c. That's what you write, right? Okay, so let us find out this. What is the inverse Laplace transform of 5s over s squared plus 1? That will be, so y of t is equals to 5, okay, times, this will be what? So the one thing that I wanted to mention is, you know, this will be 5s plus 3, not minus 3. This will be plus 3, okay? I'm sorry about that. So it just changed the sign from the beginning. It should be 5s plus 3. There was 5s plus 3, because both 5s and 3 were negative on the left side. When you move to the right side, both of them will be positive. I'm sorry that I messed up that sign, okay? So what do you get? This is 5, and inverse Laplace transform of s over s squared plus 1 will be cosine of t, right? Cosine of t. Plus, this is 3 times 1 over s squared plus 1 will be 3 sine of t. Plus, what is the inverse Laplace transform of 1 over s? 1, right? What is the inverse Laplace transform of s over s squared plus 1? That will be minus cosine of t, right? And then minus. Now, this is very crucial. So, you see that? E to the negative cs. So, c is negative, c is pi half, right? And what is the fs is 1 over s. So, what will be the inverse Laplace transform of 1 over s is 1, right? So, but 1, but that will be f of t minus pi half, but it will be still 1 because the inverse Laplace transform of 1 over s is 1. So, this is s, okay? So, this will look like u pi half t times the 1. That's what you get. U pi half t times 1. And then plus, how about here? It will be u pi half t times f of, so what is f of s? That's the Laplace, that's the uppercase f of s. That's the Laplace transform of cosine, right? It will be the function of lowercase, it will be cosine t minus c is pi half. So it will be cosine t minus pi half. That's what you get. Okay, so what do you get? You see that, is there any like terms there? Yes, there are like terms. What are the like terms here? It is like, let me see that, 5 cosine t minus cosine t will be 4 cosine t, cosine of t, right? And then plus 3 sine t plus 1 minus, you can factor out u pi half t if you want to, or you can just keep it, it does not matter, minus u pi half t plus u pi half t times cosine of t minus pi half, like that. So this is the final answer. This is the solution of that function. So our question has the right hand side function as a discontinuous function, right? It was a step function. We denoted that by the index function later on. Okay, so this is the solution. This is the final solution. Okay, so if you want to plot this, how do you plot this? You will be plotting, so all other things will be the same, only this thing and that thing, right? These two things. When you plot this, what does that mean? That means this function means, what is this function means? This is 1. This function is 1 after, this function is 1 after after pi half, right? This function is 1 after pi half. This function is also 1 after pi half. Okay, but less of pi half, this function will be 0, this function will be 0 as well. So you can plot that way. We'll be plotting just these three things. Left of pi half, left of pi half, you will be plotting just these three things, and right of the pi half, you will be plotting the whole thing, while keeping this as 1, this as 1. Okay, that's what you will be doing when you plot it. Okay, and you can plot it in your calculator, wherever you want to plot. Okay, all right, so this is how we solve a differential equation if the forcing function or if the right hand side function is discontinuous. Okay guys, all right, thank you. So you can practice more problem from the book. Actually, this was the example number 1 from the book. Okay, so if you want to practice more problems from the book, just practice example 3 and 4. So let me write down that practice question number 3 and 4 from the book, that is section 5.6. so you can practice those. Okay, and in 5.7 you will see the applied problem. Where do we apply this kind of discontinuous forcing function? You will see that, okay, in 5.7. so you will see similar problem, but they are the word problems. Okay guys, all right, thank you.